All right, everyone. Welcome to this week's meeting. I think we got a couple of topics that we bounced around. We started on them last week, but I think the two areas which are sort of combined that we should talk about is the OpenConfig versus gRPC. So what's the best way to structure the API around this? And then, of course, it would also be good if someone can provide an understanding of the Yang pipeline generation and what that process looks like. So are there any, excuse me, are there any inputs related to where we think the best way to structure the API would be? Right now, we've been looking at gRPC, generating protobufs, but we've also had the discussion around Yang models, OpenConfig for the networking, and then, of course, we need to understand how that would extend out to some of the other areas, including storage, security, AI/ML, et cetera, as we continue to expand the API. So any thoughts around that? Can everybody hear me?
Yeah, we can hear you now.
Okay, let's make it sure.
Anybody had any experience with OpenConfig? So help us show the example in Yang model generation to gRPC GNMI APIs.
Okay, so I no longer see the button to raise hand anymore. I'm not sure why, but we've tried exploring OpenConfig. We did that specifically because there was a time where IPsec was not added yet to the OPI repository. So at that time we had looked at OpenConfig, and then we did try some open source tools to translate Yang to protobuf. I forget the exact name, but I think there was something called Y2G is what I remember. Some utility like that.
Yeah, it's similar to that. I agree, Prasad, that there is something similar to that. I've also tried it, but I have been unable to get it to properly work. And it could just be an environment setup issue I haven't resolved yet.
Okay, so yeah, that's my experience. So someone in my team has tried that out, and that's all we have played around. What really got my attention was, I think someone on the last call said that even the pipeline will be visible as part of the generation. That I was not sure, because we hadn't had any such sense when we were experimenting. And I think this whole Yang conversation started with the thought that, can we generate out the protobufs? Can we generate out the code needed to handle the protobufs, I guess, the stubs at least? And then can we also provide implementers a picture of how these API may be sequenced or called, or some aspect of the architecture and pipeline? So if Yang can provide all those aspects, then I'm all for it. I mean, it does seem like a better platform to begin with. I don't think it changes our decision to use gRPC, is my opinion, right? Because ultimately that's going to be what the external agents are still talking. It's just that instead of coming up with manual protobufs, we want to find a slightly higher level abstraction to generate that aspect. That's my thought right now.
Right. I've seen the same thing, and what I've had to do to at least initially start to get around it is to take the Yang model and basically manually map it into a gRPC protobuf, which is, is relatively straightforward to do. It just takes a little bit of time.
Yeah, I tried to look into it a little bit. It looks like they have a GNMI API interface as well, which looks like does it under the hood, but I haven't really been able to figure out how that works.
Okay. Well, at least at least we're aligning and seeing that it's something that everybody is experiencing the problem with who's tried it. So it's not that we're missing something at this point, unless there's someone who knows there's a trick out there that we haven't come across. Richard, did you have something to?
Yeah, as OpenConfig for Tencent, we have used OpenConfig YAML model. I will check with my team to see if we can provide something. Boris has sent a message in the Slack thread. I will see if we can help about this. In general, the YAML model, in the OpenConfig, the JMI proto buffer is very simple. The YAML model definition is just a path, for example, the interface name, and also the FEC setting, something like that. It is all the YAML model field and the parameters are filled into the path of the JMI request. So the YAML model is not used to generate, for example, the port YAML field is not used to generate a port buffer for port. The JMI port buffer is just one port buffer. The YAML model field is used to fill the path in the path parameters in the gRPC request.
Okay. So it sounds like
Can
your
we-
team may have
Richard,
mapped it directly.
Yeah. Can we actually have take one example of very simple YAML model and just to generate GNMI gRPC APIs and see how it looks like? I would really like to.
Okay. Could you send me a message in the Slack to see what you need? I will check with my team. As you know, we are all based in China, so the Chinese New Year is coming. So maybe I cannot provide a demo maybe in next meeting, but I will see if I can send a document about this to you to the API group. Is that okay?
Yeah, that's a good start, but we need to start committing the YAML models, the YAML files. We need to start committing them in our repositories, create the build scripts to generate gRPC from it and start testing it.
Okay. Just one more thing, the OpenConfig is used for network scenarios, especially for example, for the data center network switch configuration. So I'm not a storage expert, so I'm not sure whether it can be used for the storage scenarios.
No, I think storage will be separate.
Okay.
Just the
For
network.
network is, for example, for the IPU or DPU configuration of the ports or queues or something like that in the network scenario, I think OpenConfig should be a good start. It can be easily adapted to all the management system in our for example in Tencent network management system. We all use the OpenConfig YAML model, so it will be very easy for us to adapt to the IPU or DPU.
Yeah, I understand, but we need to see a real example. We need to see the server, YAML model, generated gRPC, creating the gRPC server, running it on the DPU, IPU, then using the same YAML model, generate the client code, send it, or using the other OpenConfig tools to configure that DPU. I'm just looking into having a real example in my hands so I can play with both client and server side and see what code is being generated and how the communication is working between them.
Okay, I will try check with my team about this. And one more thing, you can dig about the Sonic management framework. In the Sonic, it also uses OpenConfig YAML model.
Yeah, that's correct. But a lot of that has been mapped. They took the Yang models and mapped them to protobufs.
Yeah.
But where do you say, Mark, when you say mapped to protobuf, is it just a manual process or there is indeed a tool to generate from the YAML model the protobufs?
So if you look out there inside of, I think it's inside of PyYang, there's a tool that's supposed to be able to generate protobufs from Yang models. I have not been successful in getting that to work. And I think Prasad said the similar thing from someone on his team. They were unsuccessful in getting it to work. So I have done manual mappings versus doing the tool. But it could just be I don't have something set up correctly or whatever, but I've not been successful in getting the tool to work.
Yeah, I can also just check within my team, see exactly what was attempted and whether they have any further updates. I'll perhaps have them send out any message on Slack.
Yeah, for some reason, my hand raise is also not working. So we evaluated it when we were starting to define our protocols for our product. And gRPC was preferred because it had a lot of tooling to include options to define, programmatically enforce ranges, limits, dependencies on enumerations. Those kind of things did exist in gRPC. I'm not saying Yang doesn't have it. If Yang has it, the auto generation should be able to translate that to gRPC as well, ideally, because anything that gets generated off of that should then be leveraging all the constraints that we want to put, like, for example, which fields are optional, which are mandatory. All that could be very easily specified in gRPC through options and extensions. So we preferred that that gRPC for that reason. I'm sure Yang has something in Yang, I think the modeling language has something in there, but it'll be a good aspect to see. Besides doing basic definition, can we really go beyond that and see if we can we can use optional versus mandatory fields. We can use it for defining ranges and limits and enforce that automatically in the generated code. If we could define the dependency and enumerations and one-off fields in the protobufs, those kind of things will be good to know. I'm not saying it's must have. In worst case, we'll just document it and do it manually. But gRPC does provide all these things in a programmatic way.
And what do we want to start with, Vipin? We want to start with basic.
Let's say that,
interface, routing, tunneling, forwarding. What do we want to start with?
So what I was going to do was based on the previous thing. Again, this is not final, but I will probably push a PR based on the discussions we had. Again, I'm not saying that it has to be gRPC versus Yang or anything. We can change it to Yang, but take that PR as a way to say what fields are needed as a bare minimum for cloud infra thing that I was mentioning. And we could take interface proto and see if we could translate that into Yang model and auto generate things from there. I think auto generation is very important.
Yeah, I think I agree with you. I think this is exactly the exercise we need to do. Take the interface proto, try to model that in Yang, generate protobufs, gRPC from that, and see if those are the same, what is the difference. This is exactly what I wanted to do. So interface, this is what you're saying is a good start.
Makes sense.
And in parallel, we can continue trying to get the Yang models to generate a protobuf. So. Okay. Any other discussion points around this complex topic? Okay. That was primarily what I had on the agenda for this week, to continue our discussions around the structure and stuff. Did we want to continue to discuss architecture definition, or do we just want to keep that as an action item that we need to go off and kind of clean up the architecture view of the API so that as different people join in, there's a clearer view on what the overall architecture of the API looks like?
I think maybe useful to continue kick off the Kubernetes discussion, Mark, again.
Yep.
A lot of people here are interested, and Prasad.
Yep. And that was next. So given all of that, we'll keep those things on the action list, and then let's start by bringing up the Kubernetes discussion. Prasad, you've raised your hand.
Yeah, no, I think Boris said the same thing, and I was echoing this. I think we can switch to Kubernetes and let's table the architecture discussion until we get a handle on what Yang can offer and whether that's still an open question or not.
Okay, yeah, and I think I finally fixed the hand gesture. So Tim, I think you've got your hand raised.
Yeah, thanks, Mark. So I was reviewing the recording from last week since I couldn't attend live. And I came away a little confused about where we left the pipeline topic. I know we have a thread going on the mail list about that topic. And, I feel like we're defining APIs to configure, elements of the pipeline. And I'm not sure that we should be trying to define what the pipeline in its entirety might look like, because that's a lot of the value add of the different DPU vendors, right? Is how they build and put their pipelines together in the data path. But maybe we need an API that can express the pipeline that's there as a capability, and there's some ability to interconnect the pieces. I really don't know, because that might actually be what the application should be doing that's running on the DPU. But I do think that whole topic to me is kind of scary when we start to say, hey, here's a pipeline and it has these 8 components connected in this way, because now you're really telling the silicon vendor how to build his chip. And I just don't think that's our role.
I agree with Tim. I think that we should focus small, and because this is a scary topic, we need to start small and configuring individual components. I think this is the right approach. We have the net interface, we have the IP, we have the basic configuration, we have the routing, tunneling. We can start addressing all of those, and once we see something already produced, we can start seeing if we can build a pipeline, chain those operations together or not.
Right. Yeah, a different API that expresses the chaining mechanisms and is built on top of the other APIs that are for the configuration of the base elements of the chain. Okay, I was just a little confused about where everyone thought we had left that topic. Is it the opinion that we're still evolving that discussion on the mailing list thread?
I don't see it evolving much anymore, because I think it came about when we were talking about Yang and Protobuf.
Yeah, it led into that discussion for sure.
And it led into pipelines, but then there's an additional thread that basically comes back and basically said Yang is not the pipeline, even though you can like set up a flow type configuration with Yang. It's not really defining the pipeline. At least that's what was my understanding in reading through the different threads.
Yeah, okay. Well, it sounds like that's a parked topic for now then.
Yeah, I think we can park that one for now. We can
Okay.
come back to it if it comes back up, and we can start talking about how we interconnect different things, which was what we talked about months ago. How we stitch together services, things like that.
Yep. Okay, so I'll yield the floor and let's talk about Kubernetes.
Yep. Okay, Boris, did you have something you wanted to start on the Kubernetes discussion, or just opening the floor for Kubernetes?
Opening the floor, people can jump in and talk. I want to address Vipin's comments in the Slack channel about the 2 approaches that we basically have, and maybe one of them is not viable. I just want to really focus ourselves to something that can be solved and not just something that we do that nobody uses. So we can start with that discussion or just open the floor.
So I have a comment, Boris. Listening to some of the comments on the Kubernetes We were talking about the use case stuff and the cloud use case versus Kubernetes, but then it occurs to me that when you say Kubernetes, that in itself isn't a very precise term. And in fact, there are multiple CNIs, right, with Calico and OpenStack. And so if we say Kubernetes is a use case, do we really need to say Calico Kubernetes or OpenStack Kubernetes? And those are different use cases because their networking models are so different.
Absolutely, I agree with you, and this is what I think we've been trying to address in the Slack. So IPDK, for example, took an approach that they are working with Calico, trying to accelerate Calico specifically. One of the reasons, right, correct me if I'm wrong, but one of the reasons is because Calico is based on OVS.
Calico is not based on OVS, or rather they have different data paths. One of them is based on Linux kernel itself. So I think the idea of IPDK, as I read the APIs, was to accelerate the Calico kernel implementation, or rather Linux kernel routing, forwarding, IP tables, all that kind of stuff. So it was for that. OVS is used by OVN, or rather, and OVS is also used by some other CNIs, probably. The third one that is more popular or gaining popularity is also Cilium, which is eBPF based. But I don't know how to offload eBPF, to be honest. I mean, we can try and run eBPF code in DPU, but how to leverage the hardware data path is something to be discussed there.
Yeah, I think my point, Boris, was we should look at these as independent use cases.
No, just to add, I think Calico also has eBPF.
Yeah,
base.
I mean, they have different data paths. Yeah, I think they moved their architecture to decouple the data path from the control plane or API layer, so they could plug in different data planes. They have DPDK based data plane. They have, initially it was Linux kernel based back when they started in 2014, 2015, around that time, and then they evolved into doing OVS and other ones.
Right. I think one of the reason Calico is advantageous for like an IPDK there is that they actually support, which is very rare, being able to run across nodes, maybe different data planes, because at the higher level, they're really just expressing everything at layer 3. And so they can, this is from their slide where I've never actually run it, but, like on one node, you can be running Linux, on another node, you can be running eBPF, and on a third node, you can be running VPP, but it's still within the same node. Most CNI or most, control planes don't let you run multiple data planes. They kind of like, you run the same CNI across all nodes that you're in your cluster. So that was kind of one of the advantages of the Calico solution.
So one thing that I didn't understand yet, and I didn't have a deep dive inside the IPDK implementation, but they claim they didn't change the Calico code. So I just wondering who is calling the gRPC APIs and the protobuffs that were defined. So how exactly that is working? If somebody knows.
Boris, my understanding is that if there is a pluggable data path in Calico, then you could adhere to the pluggable APIs, and there are no direct gRPC calls, but you're basically allowing yourself to be adhering to the data plane APIs that Calico is defining, or rather pluggable plugin APIs that Calico is defining to achieve that.
So OPI will in this, if we take in this route, OPI will be a plugin in the Calico.
Yeah, I would, because we want to, OPI is accelerating CNI. In that case, OPI would be a plugin in a data plane plugin into Calico CNI. That's the way I understand it. It'll be good to get it deep.
One or several, if you're saying that Calico, for example, supports eBPF and OVS and others, VPP. So, for example, if some vendor are we creating different plugins per implementation, per data plane, or you think we can come up with a single one across implementations?
I mean, we should try and strive to get one implementation from the DPU point of view. I think that is our goal. But we are also concluding that trying to do one for all CNIs will not be possible because they all use different ways of data path and different ways of accelerating things and all that.
No, that I understand. We can approach different CNIs differently, but from DPU perspective, you see us defining a common API across DPU vendors unrelated to the database.
I'm hoping, yeah, I think that would be ideal. So at least we don't, because otherwise the matrix is going to multiply. There are like 4 DPU vendors and 3 CNIs. So we are having 12 ways of solving Kubernetes itself. That is really not where we want to go.
But let's say Calico today with OVS is using OVS DB APIs, right? If I understand correctly. So why would they want the plugin for gRPC APIs OPI instead of us implementing just OVS DB APIs on the DPUs, for example? Just asking maybe stupid questions. But...
Yeah, I think Boris, maybe you're assuming that OVS is their leading data path solution. I don't think it is. I mean, Calico, most of the deployments and most of the use cases for Calico is not OVS based, is how I understand it.
Yeah,
It is kernel. Yeah, I agree with that. Calico is heavily Linux kernel based.
Correct.
But I also, so I did spend some time trying to understand, do they have a clean enough separation to support, for example, they do have VPP as a data path. And we did explore whether they have a clean enough separation to support VPP versus the kernel. Unfortunately, the way I see their current code repository itself being maintained, their claim for VPP is currently experimental, and B, they have actually replicated their repository and they've had to make a bunch of wholesale changes to their current architecture, the one that's non-experimental, the one that's they claim stable. So I took their ability to support more than one data path with a pinch of salt. As a result, I suspect that it's not.
Perhaps educate us. Let's say VPP, right? So they have already a method to configure VPP, right? So why would it be different with a regular server, switch, or DPUs? Why not to continue the same APIs that you use to configure VPP on the DPUs? Why we need this abstraction?
Okay, so one simple reason for that is VPP allows various means of external configuration. One of them is through shared memory, and Calico uses that. So if we can change Calico to say, oh, your VPP might not be over shared memory, but through a different channel, and now that channel is over maybe the PCI bus, then so basically it assumes the VPP is just sitting as a sidecar right there, right? So those are the assumptions that these CNIs make.
I'm just struggling between two approaches. Let's say we tackle Billy. Sorry, you have something to comment. Go ahead.
No, go ahead. But I think if I understand what your question is, I have some of the same, like, what advantage is OPI putting these abstraction layer in there? Is that what you're asking? Or yeah, because I mean, for example, we're with Red Hat, we're using OVN Kubernetes, which is calling into OVN, so which is setting up our provisioning OVS. So if we were to follow this model, somewhere in that chain, like OVN Kubernetes would have to call OPI, who then is turn around if we have something like NVIDIA or Marvell, which would then we would be running OVS down on the DPU. So you're actually adding a layer just to go back to what we already have. Is that what you're saying?
Exactly.
Yeah, and that's what I'm struggling with now. The problem is
from Red Hat perspective, this is a question to you, Billy. From Red Hat perspective, I want to ask, okay, let's say this is the model that you go in forward with, and you have your SDNs as OVN, OVS, OVSDB, all of that is fine. What OPI can actually help you as a Red Hat OpenShift to facilitate? Where can we play? Let's say you have OVS on NVIDIA, but you have P4 pipelines on AMD Pensando. How you will resolve those questions? Maybe here we can find an answer.
Right, and I don't have the answer, and that's where when you're saying we need protobufs defined, I have yet to submit anything because I haven't got my head around what that would look like. And so in one way it would look as you almost do a check, like if I'm on an Intel or Pensando, then I have to add a layer that says call OPI so that it can provision a P4 data plane. But if it's not, we don't want to add another hop in the middle because we're already struggling with trying to make this stuff efficient, with multiple nodes, and adding another hop is just going to add too much churn. So it doesn't make sense to add that hop because, I mean, the advantage would be, you can just have the same something running, the same database, you pop out one card and plug in another, but realistically, that extra hop is not advantageous at all. So I'm struggling with what you just asked. That's what my struggle is.
If we take, for example, a resemblance with storage in Kubernetes world, right? So in storage, we have CSI drivers. So we, for example, as Dell EMC, implemented a lot of CSI drivers for all our storage products, and Ceph Storage, for example, right, from IBM as well. So there it's very simple. Inside the CSI drivers implementation per storage, the storage vendors can actually call storage OPI APIs. This is what we demonstrated, and this is the direction that we're taking. So the abstraction there is very, I think, straightforward. Instead of going NVMe over Fabric directly to the target storage, we're calling OPI gRPC APIs to configure the NVMe over Fabric storage from the DPU perspective with acceleration and all of that goodness. So I do understand in the Kubernetes storage world how to implement and how to actually use it without extra hop. So that makes total sense. For networking,
and also in storage, aren't like 90% of the, or I don't know what the number is, but it's a high percentage, similar implementations where, it's a cleaner interface there.
Yeah.
Yeah.
So for networking, I'm struggling because I'm not an expert and I don't understand exactly the layering that is happening. If we take in Calico as an example, and let's take the, I don't know, IPDK approach with extending those APIs like Vipin explained, then you don't introduce another hop, right? You just somehow know that you are talking to DPU, and then you'll call into those APIs instead of, or in addition. Now I'm confused if we should implement all APIs or.
So with the CNI world, one of the things that happens is that there has to be consistency in the CNI itself. So we can't just run Calico on one node and Cilium on the other. They're not compatible. So that's sort of the fundamental problem. I think with CSI, maybe you don't have that much of an issue. But with CNI, that consistency is needed. And the only CNI I have seen which actually supports something of a backend as a concept is Flannel CNI, which is a very simple CNI. A lot of people use that to layer it on top of additional CNI because it allows chaining. So Flannel has this concept of VXLAN backend or an IPsec backend, simple backends that it provides, but it has that abstraction that it already. But the more complex ones, because they're trying to implement and chain services together, and ACLs and load balancers and things like that. So now the whole thing carries forward into every node, and it's not possible to then have differentiating aspects. So that's where I see CSI and CNI not perhaps aligning.
I'm not looking in, just to make sure, I'm not looking into combined solution. I just give it as an example. I don't think that we will solve CNI and CSI in the same way.
No, I was just trying to highlight where things change for CNI. I think that's one. So we can't have drivers per node and say, okay, they'll still be compatible somehow. So we can't have, for example, a Marvell CNI on one node and an NVIDIA CNI on the other. because the entire network must work as one though, right? The fabric needs to work as one. That's going to be the fundamental ask.
Interesting. Carol from Ericsson speaking. I think we should clearly differentiate between the internal network that the CNIs control and the external connectivity of a Kubernetes cluster. And in my view, the value of IPU offloading would be rather in the latest case, which is not really an integral part of the Kubernetes network definition. I mean, that's how you actually can connect to gateways and so on. That's really.
Why, Jens? Just wondering why? Because I did see a lot of demand for inter-pod communication as well.
Yeah, but I mean, the CNI sets up and they basically assumes an L2 networking. Calico works, of course, can work basically because an L2 network. And of course, we can have the IPU, DPU realize such L2 network, but that's not much benefit of doing that. There's not much value add in that. Whereas if you go to network address translation and similar features that you need to do on the border of the Kubernetes cluster, there's lots of things that is pretty advanced and needs the capabilities of a networking device as can be realized by IPU, DPUs.
I thought Calico operates at layer 3.
Yes, it interworks at layer 3. It's basically a BGP speaker, and it interworks and maintains the topology between the Kubernetes nodes based on BGP, but the actually underlying support is just an L2 network.
Mm-hmm. Billy, can you comment on from the OpenShift perspective, like what is the most interesting use case between the pods inside the Kubernetes cluster, or like Jen saying outside to gateways and stuff like that?
I mean, I think it's both. I mean, we're planning on using the DPU to accelerate pod to pod, even within the same node. So I mean, the goal is to accelerate as much as we can.
Yep.
But yeah, pod to pod within a node is currently being, we have those flows being offloaded to the hardware currently. So I wouldn't say that just external traffic is the only advantage of accelerated DPUs.
Would a dual CNI approach make sense in a sense that you have a thin CNI that's OPI compatible and runs on the x86, and the real CNI that the customers are interested in actually goes into the DPU, like be it Calico or Cilium, and then we just write an OPI layer that programs Calico or Cilium? Would that make more sense? Because that the commonality is needed on the host side, and internally there can be more flexibility. Folks
Even if that's true, as you see, Billy said, what they implemented, they implement SDN inside the DPU, so they're not really interested into APIs outside. They doing their own APIs between those two instances on the host and on the DPU, right, Billy?
Yes.
The question is really independent of the host, right? We want to run Kubernetes as a node, the DPU itself as a Kubernetes node, right? Hosting its own pods and containers.
Right. Right. So and that was going to be one of my points once kind of we got to a pause was, being able to run workloads on the DPU itself as well as workloads on the host. We want to do both.
But I want to be cautious. Not in all use cases, we want to run Kubernetes on the DPUs. If we want to offload networking from the Kubernetes cluster running on the host, it doesn't necessarily force us to run Kubernetes on the DPUs. I just want to be really...
Then you're right, but then you don't really need a DPU. You can use a SmartNIC. And actually what Billy said, I agree with him 100%. And I think like what we really need to identify is we need to identify a use case that DPU makes sense for it. And maybe, I don't know, maybe what is interesting to solve in the first place for example, we have a concept of service mesh in OpenShift Kubernetes. Basically, service mesh is a software infrastructure for microservices architecture that gives you security, visibility, and all these things that you need in microservices architecture. And I think the DPU it can bring a lot of value in this use case because you can take all this service mesh like
Let's be more
workload-
concrete, Naftali. I understand that, but this is very high level for me, or maybe even next item. Let's be very concrete. We
Okay,
have a
concrete.
Kubernetes cluster running, for example, OpenShift. I don't care which
Yeah.
one. Running on the host, they running the SDN controller inside the DPU. They
You
doing
don't need-
OBS and OVSDB. How
Yeah.
can OPI really help here? I
Oh,
don't.
okay, I give you the answer. Let's be again more concrete. For example, what you have in OpenShift cluster, you have ingress traffic. And most likely this ingress traffic will be over TLS, it will be encrypted. And the problem with TLS is the general purpose compute x86 is not very efficient with dealing with such workloads. And here, like the ingress controller or the ingress thing is a subset of the service mesh. And what you can do, you can take this TLS ingress traffic and you can first offload it from the x86. And in the second step, you can accelerate it with special hardware to make it much more efficient. And this use case for me is interesting because this is the first time we're speaking about a DPU and not a SmartNIC. Because this is not something you can do with a SmartNIC. This is pure DPU use case.
Yeah, but
And-
offloading a TLS or accelerating a TLS is one thing, and running the actual container on a DPU, this is something else. So I can agree with the first one, but I'm really having a hard time understanding why people would run the actual container on the DPU itself. Why?
Billy is running it now, so Billy can explain
Yeah,
you
now,
why.
why? I know he's running it.
Why? I have a very good explanation why. Because think about it like this. When the traffic, let's think about what I think the classical model with Intel. The traffic comes to the IPU, and then the traffic goes up to the x86 node. And then you want to take this TLS and you want to accelerate. And what you do, you probably use Intel Quick Assist technology, and you send this traffic again over the PCI bus to the Quick Assist technology card, and then it gets decrypted, and then you send it back over the PCI Express bus on the x86. And for me personally, it does not make sense. For me, what makes sense, the traffic hits the DPU first, and when it hits in the DPU, you accelerate it using the hardware accelerators you have on the DPU, and you decrypt the traffic, and then you can already know, okay, I have this workload on a node connected to this DPU. I will just forward it to the relevant application. Okay, this is a concrete use case, and this answers, I think, your question why.
Yeah,
And-
this answers why this answers TLS offloading. This is
Yeah,
Yeah,
I
so-
think
so-
Rabi, let me chime in. I think what is happening is we are confusing between the pods for infrastructure versus application pods. I
Yes.
don't think anyone is proposing running application pods on DPU. I think what people are proposing is running the infrastructure daemons or daemon sets which are running on these Kubernetes nodes for infra services like CNI itself or for kubeproxy equivalent. They be run on the DPU to avoid the back and forth between the host and the DPU itself. That is, maybe that clarifies the confusion and also gives a point as to if you have ARM cores in the DPUs, then why not run the infra service pods on the DPU itself and let the applications run on the x86 standard host, and that's perfect. Because I mean, you have a whole bunch of x86 CPUs, you are going to use them for running the application. So that is perfect. But once the traffic is handed over PCI lane to DPU, then it doesn't go back and forth. It gets processed completely inside the DPU and then be sent out on the wire. Or on the way in, it gets completely processed and delivered to the application natively.
Right, I agree with Vipin that we're talking applications versus infra. And maybe you have some front end you want to run from infra. Maybe it's a firewall, maybe it's doing denial of service protection, maybe it's doing some type of load balancing, maybe it's doing some other special service functioning that we haven't dreamed of yet. But it's an infra that we want to do some type of service function chaining before it ever enters in, and but it's containerized and we want to run it.
I agree with that. And I'm looking into who is going to implement that infra pods is obviously like Red Hat for OpenShift. They're going to take ownership and implement those pods to run infra pods to run inside the DPUs, for example, right? We are not the experts in providing that. So my question is again,
companies like F5 will deploy products
F5,
on those
yes.
DPUs. Yes.
For sure, absolutely. Yeah, thanks, Tim. But so my question again, those companies write the software that is running inside the DPUs, how OPI can help here? Who is going to call those APIs? Like Naftali, in your example, TLS offload, I'm okay with that. Okay, this is a good use case. So who is going to call those gRPC APIs, let's say those gRPC APIs, to actually configure the offload itself?
We need to talk about this with Red Hat, but I think this is like, because when Red Hat, I think when Red Hat want to, they have a software, they have an Ingress controller, they want to offload, accelerate the TLS. And I think the vision for the OPI that they will not need to do it in a vendor specific way. So where we need to define these APIs is how, okay, I want to set up the IPsec tunnel. Okay, this is an API to set an IPsec tunnel. I want to decrypt TLS. This is the API to decrypt TLS.
I understand. So first of all, that means is we are only talking about APIs inside the DPU. We are not talking about APIs coming from outside in this case, because all those applications like Tim and Billy said, they are running inside the DPU. So APIs are local and not remote, first of all. They can be remote, but just to focus ourselves, right? Because who will configure that TLS or IPsec tunneling is going to be the application that Red Hat, for example, is writing, and Team F5 is writing and running inside the DPU. So we are developing APIs for those applications, so inside the DPUs. And second of all, my question is how they do it today without DPUs. There is a way to create tunnel, right? The strong swan application to create IPsec tunneling, VPNs, all of that kind of stuff already exists today. So why would somebody need to change that and introduce a new set of APIs instead of using the existing APIs?
Right. So at least, and this is where some of the complication comes in my head, is like those APIs are unfortunately specific. So like NVIDIA, to the acceleration is using TC-Flower to offload OVS flows. If I'm not mistaken, Marvell is using RT flow to offload more specific like OVS flows, whereas the Intel and I think Versando is using a P4 pipeline, which doesn't map to OVS flows. And so it's hard to come up with how that would work. But I think that is the offload API that is there currently today. And someone correct me if I'm wrong, especially hardware vendors, because I'm trying to get my head around this, but that's kind of how I see it. You've got the RT flow, the TC-Flower, and then the P4. And those are your, at the lowest level, those are your offload APIs.
That is correct. I wouldn't necessarily call that vendor specific, right? I mean,
they're open standards, but what the problem is, if the standard is TC-Flower, I don't have a clean way to port that to a P4. I guess you're right. They're not proprietary. They're all open standards, but you're talking TC-Flower versus P4, and they're just completely different.
No, I think this is the earlier argument somebody made, right? Smart NIC versus DPU. So these fall under a smart NIC category because the NIC or the hardware is exposing itself via a standard that's visible to the host. The standard is like the kernel environment, stack environment, or the DPDK device driver environment, or if there is a P4 standard application, then that's your environment, right? So whoever is adhering to those standards, whichever device is adhering to those standards, is compliant. And that's the way higher level applications can leverage it. So that's the smart NIC way. The DPU is abstracted already by those standards.
I would like to chime in a bit here from my experience. I mean, the advantage DPU provides over a smart NIC, and we are calling smart NIC as something that could have acceleration APIs to be called from host, and we are calling DPU as something that has its own subcomplex of ARM subsystem and offload functions that could be more tightly integrated than how a host uses it. So given that definition, the way we have been able to, in Pensando, we have been able to achieve that kind of vertical integration between the data path and the ARM software is immensely better than what a host APIs could use. I mean, it's the order of magnitude better. So the main advantage of DPU in that case is that it's not just that you have same offload APIs that you could have called from host, now you're calling from ARM complex, but the tango of ARM using or abusing the data path to its fullest is much, much better because you are independent of what goes on the host, and you can really do that, crazy vertical integration in a very neat way and provide the value that users are looking for from DPU compared to smart NICs. And in that context, I would say that if we were to take that point of view in mind, we should look at how can we break the boundaries of a standard smart NIC acceleration APIs and do much better, because otherwise people will not go with DPUs. And that's okay. I'm not saying it's a good thing or a bad thing, but if they are paying for the DPU, they should get the value out of the DPU, and they will get value out of DPU only when you get them an order of magnitude better performance than what a typical smart NICs could do. And that is possible. I'm certainly saying it's possible because we have done it. It just requires an approach of doing a much more tightly vertically integrated. Vertically integrated is a very broad term, but what I mean here is the exchange of the data path and the functions and whatever we are calling the infra services that are running on the DPU, how they leverage the data path and take advantage of all the niceties out there. It needs to overall come out better. And if we were to take that perspective, then it is possible to go beyond the current set of API definitions and say that, okay, we will open up a few more interfaces because we don't need to expose it to the standard x86 host and try and leverage that better.
Can I add one point to your definition, Vipin? I think for me, one key aspect where the DPU differs from smart NIC is that smart NIC operates, I think, as an independent device in isolation, and it relies on its host for all the configuration and information.
Right.
But DPUs, they could actually talk to each other mutually, discover each other if need be, collaborate, exchange information, state information, whatever, to keep the fabric alive.
Yeah.
For me,
So
that is
you're correct. There are multiple aspects of DPU. I was only commenting on DPU difference from smart NICs from the network acceleration point of view. You're right. I mean, you can satisfy bare metal use case with DPU, which you can with smart NIC maybe. And that is precisely because you can control it completely from the network. So again, you are correct. I'm not disagreeing with you. All I was saying was my comment was based on the network acceleration point of the difference between the two.
But what I'm saying is, just because the DPU is configured via existing standards, it doesn't necessarily reduce it to a smart NIC. It is a smart NIC if it is just a NIC for the host. It's a DPU if it's a NIC part of the fabric for the entire data center. That's the way I see it. In other words, you program it, but then the DPU has its own intelligence to then realize that, oh, I'm part of this large fabric.
Correct, but Prasad, think about from the user point of view. Why would user want to pay more to manage one more entity from the network? Why would they love doing that? Just let's answer that question, because they have to get the value out of it. And yes, they have flexibility to manage it independently, and they could do all kinds of things with it. But still, they have one more thing to manage, one more OS to operate, operating system on the DPU. I mean, they have to version it separately. This is like all operational additions that we are giving it to them. What are they getting in return? It is the performance. It is the overall, overall value that they get out of not just the performance, but maybe there are use cases like bare metal use cases and all that. So we are giving them newer use cases, and we are giving them better performance, better latency, and value that they could measure. So my point still goes back to what value we are providing to the user in that sense.
So
But let's take the
where do we
example
see-
of IPsec acceleration. I mean, that's a heavy task to do in CPU, in the host CPU. That can easily be accelerated by hardware in the DPU. But the
well, Jens, it could be easily accelerated. I 100% agree. Does it have to be DPU, or can it be on a SmartNIC?
I mean, there's a lot of control plane stuff in IPsec, and that control plane stuff would need to be mapped to the underlying hardware. So it's more convenient if the control plane, the strong one, that's actually handled in the DPU, so that the host just see a tunnel endpoint and nothing else.
I want to question that, really, honestly. I'm being a DPU vendor. I'm ironically questioning it, which is true. But if we don't ask these questions to ourselves, it'll be someone else asking that, and we better answer it.
Yeah.
So say that is operational challenge to have another system in your thing worth running IKE, or in this case Strong Swan, worth running the IKE protocol from it. If it move that IKE protocol from x86 into this one, and remember, IKE is not just a protocol. It is
I hate to interrupt you. I think this is an excellent discussion, but not to this forum, right? We are not going to solve in OPI the value for DPUs. This is for you vendors with us integrators.
I think Boris, no, this is an important question, right? So is IKE configured on the DPU via OPI, right? That's a question I've had since whatever 4 or 5 months I've been joining this forum, right?
But I think we already answered that, Prasad. We showed the Strong Swan application running inside the DPU.
So then what?
Providing northbound, one second.
Yeah.
Providing northbound APIs using Vici API to gRPC server to
Yes.
anybody to configure it, right? From anywhere.
I agree. I'm in alignment. But I think what Vipin is also saying is, okay, if somebody is wanting to do it the other way, where they run the Strong Swan on the x86, is OPI still going to facilitate that model somehow, or does it reduce the hardware to a SmartNIC? I guess that's the question I'm hearing. Does it somehow devalue the proposition?
Yeah. My point of bringing all these things is not to open the charter for OPI, but to see that API needs to be created in a way that can provide DPU value. Otherwise, those APIs are not, because if those APIs could not provide the value to the user, then users will continue with either.
I agree. And this is why we need to deep down understand who the users are. For me, the users are Red Hat, OpenShift, who put in SDN controllers and want to configure OVS, and F5, who wants to put a firewall inside the DPUs. Those are the users. And for the APIs, Vipin, that you defined, the cloud, they are the users. So it makes sense to solve it differently.
Yeah.
And it's very legitimate to actually use a DPU as a SmartNIC. Maybe it's not getting the most value out of the DPU, but there are people today buying DPUs and deploying them just like SmartNICs.
Yep.
But I don't think that's what OPI is trying to angle for, right? We're trying to worry about the new use cases that DPUs open up.
I think we need to go back to Kubernetes discussion. We're out of time, but offline and back. We need to go back to Kubernetes discussion, understand if OPI can provide value, and if yes, how that value looks like. If you're following the plugin approach from Calico that IPDK presented, that's something we can deep dive on. If we don't see any value, that's also okay, right? We need to be very frank and forward. and say we don't see value. If Naftali, you're thinking TLS offload, that's all good as a use case. But then my question is, who is going to configure that TLS offload? The SDN controller from OpenShift or Calico, and how it will look like? Yeah, those are the questions that we need to answer ourselves. Technically, everything is possible, but we need to understand who the users and how we integrate with them.
Yeah, and I would
So-
applaud the level of engagement today for everybody. I think this has been a really good discussion.
It has. It's been a good discussion today. We will probably pick up and continue the discussion on Kubernetes next week in the meeting. So let's be prepared to
It will help that people
dive deeper.
come more prepared with slides or pictures, so we can share. And this was a very good discussion, but it was lacking some visual aids for me. So if somebody, Naftali, from your perspective, or Vipin or Billy, you can come up with
Yeah, I'm happy
some
to.
blocks, it will help a lot.
Yeah, I'll present, if not the blocks, I'll present some examples of the code from various CNIs and look at that API layer that we could cut ourselves at.
Great. Appreciate that, Vipin. Thank you.
Sure, thanks.
All right, everyone. We'll continue next week. Have a good week.
Thank you.
Sounds
good. Thanks, everyone.
Sure.